Welcome to lab tutorials of Digital Design and Computer Organization, code BCS302. I am Sahana RS, Assistant Professor, Department of Information Science and Engineering, Rajiv Institute of Technology, Hassan. So before going to the first experiment, that is given 4-variable logic expression, to get to know the first experiment, let us try to implement basic gates using PSpice. After implementing the basic gates, we can go to the first experiment. Now let us try to implement 4 basic gates or 3 of the basic gates. One is NOT gate, next is AND gate, and next is OR gate. Okay. To implement the gates first, we need to click on Capture Light Edition. In this, go to File, New, Project, give a project name. As I am designing basic gates, I am giving my project name as basic gates. This is an user defined name. Okay, you can give your project name as you required. Then click on OK. Then you have to select create a blank project. Then click on OK. An empty designing sheet will be open. Here, this is the sheet where you have to design your circuit. Initially, we are not going to design any circuit. We are just going to implement some of the basic gates. Okay. First, we shall implement an AND gate. Okay. Go to place, part. Here, AND gate, OR gate or NOT gate, the name of your gate is not given directly. If you want to select the gate, you have to give its IC number. We have list of IC numbers. Let me show you the list of IC numbers first. Here is some of the list of gates and their IC numbers. We have NOT gate with an IC number 7404, 2 input AND gate with an IC number 7408, 3 input AND gate with an IC number 7411, 2 input OR gate 7432, NAND 7400, NOR 7402 and XOR 7486. In this excepting NOT gate, let us design 2 input AND 2 input OR, NAND, NOR and XOR together. So go to capture light. Here to select your required IC, go to place, part, search for IC number 7408. You will get your AND gate. Take it. Click on OK. You can place the gate wherever you require just by a click on mouse. Okay, then after placing your gate, right click, click on end mode. Next, to place other gates, go to place, part, 7432 is our OR gate. Select, click on OK, place the OR gate. Okay, next end mode. Next, place, part, 7411 is a 3 input AND gate. Now we are going to design only 2 input gates. Okay. Next we shall design NAND gate, that is 7400. Okay. Select NAND gate, place it, click on end mode. Again go to place, part, select 7402, NOR gate, OK, place it. End mode, place, part, 7486, XOR gate, select, end. Now we shall give the input to gates. We know that if we have 2 variable inputs or 2 variables, then we will have 4 combinations of input. The truth table for two input gates is as shown here. Different gates are shown here. The first truth table is for A and with B. When we have input 0 0, the output of AND gate will be 0. For input 0 1, the output of AND gate will be 0. For input 1 0, the output of AND gate is 0. The output of AND gate is equal to 1 only when both the inputs are equal to 1. Next, we have truth table of OR gate. For 4 combinations of input, we have 4 combination of output. We can observe for combination 0 0, the output is 0. For all the remaining 3, the output is equal to 1. This is XOR truth table. The XOR truth table has only 1 when we have 2 inputs not same. That means we have, if we have 0 1 combination and 1 0 combination, the output is equal to 1. But for 0 0 we have 0 and for 1 1 we have 0. That means this gate is also called as OR gate because the output of this XOR gate is equal to 1 only when we have odd number of ones. This is a truth table for NAND gate. NAND gate is nothing but the complement of AND gate. In AND gate, the first 3 input was equal to 0 and the last was equal to 1. Here we have complement of AND gate. The first 3 inputs are equal to 1 and the last is equal to 0. The last gate we considered here is NOR gate. The NOR is complement of OR. Okay. In OR gate, the first output was equal to 0 and all the remaining outputs were equal to 1. In NOR gate, first output is equal to 1 and all the remaining 3 are equal to 0. Now, let us implement and simulate the basic gates and check whether the simulation is same as the truth table. Okay. For 2 input, we have 4 combinations of inputs. So here we have 2 zeros. That means for A input we have 2 consecutive zeros and then we have 2 ones. For input B we have 1 0 and 1 1. If you consider this as one time unit, then for 2 time units we want A to be at a 0 condition and the next 2 units it has to be equal to 1. When we consider for P, it has to be 0 for one time unit and 1 for the next time unit. Okay. Now let us see how to implement this truth table in a PSpice. Okay. So to give the input, we need to go to place, part, search for digiclock. Okay, select it, click on OK. You have to give it for input. Here all the gates has similar inputs, so I am using only 2 gates. One is considered as A and other is considered as B. So I will draw a wire to connect this A input to all the gates. Next, input B is given to all the gates. Observe, except the connection, there must be no nodes created. extend the output click on end while. So observe the truth table. As I said earlier, for two time instances or for two time units, the input has to be 0 for A, and for two instance, the input has to be 1. Then for B, for one time instance, input has to be 0, and for other next time instance, the input has to be 1. How to implement this in digital clock? Here we have off time. I already said for A, it has to be 0. Off state means that is 0, on means that is 1. So for 2 units of time, A input has to be 0, and the next it has to get on after 2 units of time. Then similarly for B, it has to be 0 for 1 unit time, and 0 for 1 unit of time. Click on OK. After assigning inputs and also establishing the connection, now we have to name the inputs and outputs. We have A and B are my inputs. To name the inputs and outputs, we need to go to place, net alias. Okay, you can name A, B, C. I have named one input as A and the other input as B. Now you also have to name the output. I am labeling output as C for AND gate, D as output of OR gate, E as output of NAND gate, F as output of OR gate, NOR gate, G as output of XOR. Okay, then click on Enter. After labeling and giving the input, now you can simulate the circuit using PSpice. If you want to observe, you can observe we have given 2 microseconds off and 2 microseconds on for input A, and 1 microseconds on off time and 1 microseconds on time for input B. Now let us see how to simulate this experiment using PSpice. The experiment, go to PSpice, select new simulation profile, give the simulation name. As I am designing basic gates, I will give the name of simulation also basic gate. Then click on create. You can observe a window is popped here. So click on that. You have to tell the runtime. That means for how much of time your graph has to be displayed. Okay. You can write 16-20 microseconds. Okay. The graph will be presented very nicely if you give less time as possible. Okay, if you give 400-500 microseconds, the graph will not be readable, so give less amount of time. Step size will be 1 microseconds. For each and every 1 microseconds, I want my input to be changed. Okay, then click on OK. After this, you need to run the program. Go to PSpice and run. A simulation window is created. Okay, go to the simulation window. Initially there will be no graph present. So you have to go to trace and select the graph to which you have to see the output. So we have A, B as my inputs, and I also have C, D, E, F and G as my output. Okay. If you find it confusing, you can select A, B input and individual C output, D output. Okay. However you require, you can select it. I have selected all my outputs. Okay. If you find it confusing, go to trace address. Just select A and B are my inputs. C is the output of AND gate. Okay. Now we shall trace the output. Go to click on toggle cursor. Place wherever you require. You can observe A and B and value are equal to 0. When A and B are equal to 0, the output of AND gate is equal to 0. That is shown in C. Okay. When input is equal to 0, 1, the output is equal to 0. When we have input 1 and 0, the output is equal to 0. And when the input is equal to 1 and 1, the output is also equal to 1. Okay. This is the output of AND gate. Next, run the graph again, add trace. Now you take A, B and D as your output. Now you can trace. This is the output of OR gate. For 0, 0 combination, output is 0. For 0, 1, the output is 1. Again for 1, 0, the output is 1. And for 1, 1, the output is 1. Similarly, you can check for NAND gate. Okay. The NAND gate is complement of AND gate. AND gate output was 0, 0, 0, 1. That means 0, 0, 1. Now you observe the NAND gate output is 0, 1 and 0. Okay. Similarly, OR gate and XOR gate output can also be observed. Okay. Trace. A, B, F. Here you can observe 0, 0 is equal to 1 and all the other three outputs are equal to 0 because NOR is a complement of OR gate. In OR, the output was 0, 1, 1. Here we get 1, 0, 0. The last is we have G. Okay, that is XOR gate. You can observe here. For 0, 0 combination, the output is 0. And for 0, 1 combination, the output is 1. And for 1, 0 combination, the output is 1. And for 1, 1 combination, the output is 0. You have to observe only G because G is the output of XOR gate. F was the output of NOR gate. You don't want to worry about the F. You just observe G. For 4 combination, 0, it is 1, 1 again, and it is 0. This is the implementation of basic gates. The basic can be implemented individually or all together you can implement. The basic gates implementation also be extended with 3 input AND gate, 3 input OR gate or 3 input NAND gate. Okay. Everything is a similar. Okay. Just we need to give 3 inputs for 3 input NAND gate. Okay. You can follow the same steps